Okay, so in this video we are going to be looking at the nth term of a quadratic sequence. So we've already looked at the linear nth term, but the nth term for a quadratic sequence is different because it's a different type of sequence. So as always, we're going to start off with our sequence. So this one goes 4, 9, 16, 25 and 36. So as always, we are going to start off with finding the differences between each of these terms. So 4 to 9, we add 5, 9 to 16, we add 7, 16 to 25, we add 9, and 25 to 36, we add 11. So then we find our second difference because the first difference isn't constant, and we find that the second difference in this case is constant because it's a quadratic sequence, and the second difference is a constant of 2. So now we can go on to find our nth term for the quadratic sequence. So there is a formula for the nth term, and the formula is Tn, which is the nth term, is equal to an squared plus bn plus c. Now you might recognise that this looks a lot like quadratic equations that would often have x in them. So 3x squared plus 4x plus 5 would be a quadratic equation. So it has the same form as a quadratic equation because it's a quadratic sequence. So the first thing to note is that a in this equation is half of the second difference. So in this case, the second difference is 2. So we are going to have a is equal to half of 2, which is just 1. So now we can fill that into our equation for the nth term. So we will have Tn is equal to n squared plus bn plus c, because we found that a was 1. So now we have an equation with two unknowns. So our unknowns in this case are b and c. So if we have two unknowns, the easiest thing to do is use simultaneous equations. And we can use simultaneous equations to find our two unknowns. So we are going to start off with T1, or term 1. So term 1 from our sequence up here, we know that T1 is equal to 4. So we have T1 is equal to 4. And then we are going to substitute in the rest of our Tn equation. So we have is equal to, n in this case is 1, so we have 1 squared plus b times 1 plus c. So this is coming from this Tn equation here. So once we multiply that out, we have 4 is equal to 1 plus b plus c. And if we simplify that, we can have b plus c is equal to 3. So that's just bringing the 1 over and subtracting it. So that's one equation for our simultaneous equations, but for any simultaneous equations we need 2. So now we are going to use our second term, which in this sequence is 9. So we have T2 is equal to 9. So bringing that down, we have T2 is equal to 9. And then again, using our Tn equation, we have n is equal to 2. So we have 2 squared plus 2b plus c. So again, if we simplify that out, we have 9 is equal to 4 plus 2b plus c. And then just rearranging, we have 2b plus c is equal to 5. So now we have our two simultaneous equations and we can solve those. So if we name this equation 1 and this is going to be equation 2. So the easiest thing to do here would be to subtract equation 1 from equation 2. So if we have equation 2 here, we have 2b plus c is equal to 5. And then if we subtract equation 1, we have minus b minus c is equal to minus 3. So that's the same thing as multiplying equation 1 by minus 1. So if we subtract that, we have 2b minus b, which is 1b, or just b, plus c minus c, the c's cancel out, and then we have 5 minus 3, which is 2. So now we have our value for b, and we can use that to find our value of c. So again, if we go back to our original equation 1, we have b plus c is equal to 3. Now we know that b is 2, so we have 2 plus c is equal to 3. So c is equal to 1, just subtracting 2 from each side. And now we have our value for c. Now if we go back earlier on, we had our equation for Tn was n squared plus bn plus c. So if we bring that down, Tn is equal to n squared plus bn plus c. And then we can substitute in our values for b and c that we've just found. So we will have Tn is equal to n squared plus 2n plus 1. And this is our final equation for the nth term of our quadratic sequence. Now, after finding the nth term, it's always a good idea to check your equation. So the equation that we found for our nth term is Tn is equal to n squared plus 2n plus 1. So if we wanted to find our third term in the sequence, we would have T3 is equal to 3 squared, because 3 is equal to n, plus 2 times 3 plus 1. So that would give us 9 plus 6 plus 1. So T3, our third term, is 16. And how we check that is we go back up to our original sequence and we find that our third term is in fact 16. So that's just a way to check that the equation for the nth term that we found here is correct. You can sub in a value for n that you know from the sequence that you've been given, and if you get the same answer, then you know that you've gotten the right answer for the nth term. So that's everything you need to know to calculate the nth term of a quadratic sequence. Don't forget to like and subscribe, and we'll see you again soon.